that this function is continuous. Well, it would not be continuous at x to the fourth not equal 2, or x not equal the fourth root of 2. But this is not in this domain, plus or minus. Okay, it's not in this domain of -1 to 0. So I can check that. So I can take 2 to 1/4. And it's outside of -1 to 0, plus or minus. So I would say the function is continuous. I'm in the middle of my class. I'll call you back. Thanks. I wanted to ask you about the student opinion forms because for some reason they don't appear in my self services. I talked to the dean, and I just want to make sure that this doesn't happen to me again like it happened over the summer. So that's why I wanted you to look into in Canvas, if you like, in self-services and see if your classes appear there as the student opinion forms, because I want to announce it to my students, but they don't appear yet. So I don't know when they're going to be open. So they should be. It's always 2 weeks before the last day. That's what I texted you. I wanted to ask you. I also talked to Robin. Right. I'll give you a call after I finish my class. I don't want my students to wait. I'll call you back. Thank you so much. Thank you. So this is an important topic that I wanted to discuss. So I'm going to stop for 1 second since my colleague called me, because I called him. Why is this turning off? So it is very important to me that my students are informed when the student opinion forms are open. And I do give an incentive, like always. I give a little incentive on the final exam. If you have proof or you upload the last page where it says, thank you, I completed the survey, or survey is completed. Nothing else. You cannot upload anything else but the last page. But over the summer, this happened to me. Somehow for my classes, they opened for 1 day. Everyone else had their students having access to the student opinion forms for 2 weeks. In my case, it was 1 or 2 days. And I just want to make sure that this doesn't happen to me again. And I called 2 of my colleagues today, but they didn't check. It's normally 2 weeks before the final exams. So for some reason, this week is lost, is wasted, because my student opinion forms are not open. So he was just finishing his class and he called me because I texted him to call me back. So I will keep you posted. It's very important to me that my students get access to the student opinion forms. I take them very seriously. If you have suggestions for me and so on and so forth, this is very important to me and to my department. So, but for some reason I looked and they're not open yet. So something is, or maybe the dates were changed and I wasn't aware of it. So my apologies for the interruption, sorry. Okay, what was I doing? Yes, so I would like to replace this by a new function like 2 minus x to the fourth, as long as du is in the problem or close. It is very close. I have x to the third, and I have, of course, dx. I don't have the -4, but who cares? I can make up the -4 anytime I want. So now I will replace this by du. I will replace this by u to the 7th. And I will continue, and I have to change the limits of integration. Mandatory. -1/4. When x is -1, -1 to the fourth is still 1, 2 minus 1 is 1. When x is 0, u is 2. Do not copy the limits of integration that were initially for x to the limits of integration for u. They're not valid. So we said du divided by u to the 7th, but that is nice. It's negative 1 over 4. The integral from 1 to 2, u to negative 7 du. Negative 1 over 4, u to negative 7 plus 1, divided by negative 6, the same thing, 1 to 2. Leave the constant outside so you don't have too many calculations, weird calculations. Negative 1 over 4 times negative 6, 1 and negative 1 over 6 is positive 1 over 24. When I plug in 2, I get 1 over 2 to the 6th. When I plug in 1, I just get 1. So whatever that is, 2 to the 6th is 64. So 1 over 24. So 64. So 1 minus 64. So negative 63. Okay, I can simplify by 3, and I get negative 21. And this is 8. And can I simplify anything else? No. 2 and 3, 5, 12. Let me know if you have any questions here. I'm checking my numbers so I don't make a mistake. So negative 21 divided by 512. We expected to get a number because this is a definite integral. Now for indefinite integrals is a different story. So I wanted to choose 86. It's not a very, it doesn't look to be a very friendly one, but let's take a look. Unless you have other questions. Is this okay? Would you like to work on this, or you have other questions for me?
We can work on that.
Okay. Good. I'm thinking, so first of all, this is going to be the most general antiderivative of this function. So let's see what we can come up with. What I don't like is this square root applied to a difference or a sum, because I cannot separate it. I cannot simplify it. So I'm going to go this route. Let's say u equals x minus 2. Nice. Du equals dx. No headache there. So now this is no problem. This piece. This is simply the square root of u. No problem there. But what do I do with this? Well, I will solve for x, moving 2 to the other side. So x is u plus 2. I will replace x by u plus 2 squared. Of course, x squared by u plus 2 squared. So this is the integral from u plus 2 everything squared times the square root of u, and it happens that dx equals du. Notice one more time, this integral is in x. You cannot have x in the following integral. Everything has to be accounted for and everything changed to u. I have to square this, and we know it's u squared plus 4u plus 4. And I will have to distribute the square root of u, which is u to 1/2. Okay. The integral from u squared times u to 1/2 is u to 2 plus 1/2, which is 5/2, plus 4, 1 plus 1/2 is 3/2, and plus 4 u to 1/2 du. So now the antiderivative is u to 5/2 plus 1, which is 7/2 over the same number, plus 4 u to 3/2 plus 1, which is 5/2 over the same number, plus 4 u to 1/2 plus 1, which is 3/2 over the same number, plus a constant c. Okay, so please don't forget the constant. Now I'm going to flip all these fractions before I go back and replace u by x minus 2. But first I'm going to try to clean it up as much as possible. So 2 over 7. I can already write this. X minus 2 to 7 over 2 plus 8 over 5, x minus 2 to 5 over 2 plus 8 over 3, x minus 2 to 3 over 2, and plus the constant c. Is this better? So now you have another example of a definite, and which we do not, please do not go back to the variable from before. There is no need. This is a number. You will get the same number if you solve it in x or solve it in u, of course with the appropriate limits of integration. The number will be the same. Here we have no choice. We have to go back to the variable given in the problem, which is x, because this is a indefinite. It's an indefinite integral, and the answer is always a function. Anything else?
Why does the limit change?
The limits of integration?
Yeah.
Okay. So when I move, so these limits of integration are for x. So I'm going to copy the problem here. So x, according to this, is between -1 and 0. But what about u, which is 2 minus x to the fourth? Do you think that u will still be between -1 and 0? No. If x is -1 for the lower limit, for -1, 2 minus 1 is +1. If x is 0, then this is 2. I cannot copy the limits of integration unless I replace x by u. If I replace x by u, then they are the same limits of integration. But u is a function of x, which is 2 minus x to the fourth. If x is between -1 and 0, u cannot be between -1 and 0. Not possible. The lowest x is -1, which makes the lowest u 1. And the upper x is 0, which makes the upper u 2.
Okay, yeah, that makes sense. Thank you.
Unless you use the same, which will never be the case. I'm not going to just simply change x into u just for the sake of having u instead of x. Then you have to have new limits of integration. Good, very good questions. Anything else? Anything else?